Hello everyone. We are going to start a question that was assigned. So the group is self-study, no AI. We have to use no AI. In this subject is chemistry. Test order. First we have to attempt version A, and then we have to attempt version B. So let's get to the version A. That's version A. So let's get into it. Use the diagram to answer the following question. This is a diagram, uh, incomplete hexagon. One, two, three, four, five, six. Yeah. So there are dash carbon atoms in the parent chain. It is called. There are uh, one, two, three, four. I think parent chain four. So I think it is called five carbon atom. So I think it's D. Numbering of the molecule will begin at carbon. Numbering of the molecule at I guess carbon alpha. So go with it. Use this information along with the previous diagram to answer the following five questions. There are branches at carbons X, Y, and Z. Okay. Okay, XYZ has branches. The branches at carbon X is called 1. X has one, 2, 3, 4, 4 branches. So uh, we can say that it's cyclono. This is not, I think it's methyl propyl. There is a type of branch that is common between carbon X and Z. Z. What is it called? Uh, There is a type of branch that is common between X and Z. X and Z. This is the type of branch which is common. So we can say that it is, I think, methyl. Which carbon is able to make another bond? Able to make another bond. So X, Z. We have options X, Y, Z. Y can make another bond by having it. X also can make, no, X cannot make, Y also cannot make. So it's like I will go with the option none of the above. What is IUPAC name of this molecule? Don't know about much about this. The addition of methyl group onto carbon would cause a change only to the name of parent chain. Methyl group onto carbon would cause a change only to the name of parent change. Methyl group. I think it's alpha. Not sure. Which of the following molecules is not an organic molecule? So, benzene, hydrogen, peroxide. I think tetrafluor. I think benzene is not an organic molecule. How many valence electrons are present in butane? think it's 24, 30, I think, I guess. Which element has the same number of electrons as butane has valence electrons? Uh, I think it's iron. Iron. Okay, let's start. Which of the following functional group is most likely to emit a pleasant sweet smell? I think it will be. Can you answer the previous question? Participate in hydrogen bonding. Why or why not? I don't know about it. I have to research about these things first. Which molecule will have the highest boiling point? I think hydrogen. I think number three, because having uh, two carbon and four hydrogen with two oxygen. Okay, how many hydrogen atoms does an alkaline with n carbon atoms have? 2 n plus 2. Molecule name ethanol, 78.4 degrees Celsius. 1 heptene. Okay, use this information for the which molecules have London dispersion forces. I will go with something ethanol. I will go with it. Assume each substances is a liquid temperature. Which of these molecules can mix with water? So, uh, don't. I will go with ethanol only. Why can they mix with water? So I don't know about it. Despite that, decane does not have a permanent dipole. Its bonding point is much higher than ethonic acid. Why? Decane can participate in dipole-dipole interaction. All other molecules contain oxygen, so oxygen decreases boiling point. Uh, I will go with it. Random guess. Where would you expect methanol to place in this list? Uh, Between ethanol and one heptane, I think I will select this. The Okay, use this diagram to answer a following four question. The addition of a methyl group to which carbon would not produce a molecule with side chain. So, with the addition of methyl group to which carbon would not produce a molecule with a side chain. Mm, I think it's all of them would produce a molecule with a side chain. The addition of methyl to which carbons would produce the same molecule. How many valence electrons are present in this molecule? I don't know. What is the maximum number of propyl groups that can be added to carbon? So, what is the number of propyl groups that can be added to carbon A? I think zero. The electron in a benzene molecule are not fixed on one atom. They are dash. I don't know about the theoretical part. So, an acidic flavor compound has been discovered. It is naturally dissolved in an organic solvent that is it is unknown non-polar. It does not have any natural odor or color. In the lab, you have presented with five vials that may contain the flavored compound. How will you attempt to detect its presence? Add orange dye, artificial orange dye will absorb into an acidic compound. Add water, an organic compound will ready dissolve in water. Okay, I don't know. Titrate using HCl. HCl will decrease the pH past zero. This indicates the presence of acid. Titrate using NaOH. NaOH will neutralize the solution. I think it's uh, titrate using NaOH. NaOH will neutralize the solution. So that's it for now. Let's uh, check the result of this. So okay, I got only 7 points. So these 7 points are all belong to random guess, but not this. I think I have calculated correctly. One, two, three, four, five, and six. It's hexagon. Okay, numbering of this molecule will begin at carbon. Okay, use this information. Okay, this is not methyl propyl, it's methyl cyclopropyl. This is what which carbon is able to make another bond. I said that none of them. What is IUPAC name of 2 cyclopropyl, 3 ethyl, 2,4,4 trimethylhexane. So I have to research on it. The addition of methyl group onto carbon would cause a change only to the name of parent chain. So don't know about it. So I have to. Which of the following molecule is not an organic molecule? So I also have to research on it. Okay, that guess has been worked. So which of the following functional is more? Can you answer to the previous question? Participate in oxygen bonding where or why not? No, there are oxygen atoms, but they are not bonded to any hydrogen atoms. Okay, which molecule will have the highest boiling point? So it will be HCOOH. Don't know why. So looking at this, I think we have to get onto it and do some research on it. So according to this, we have to. So let's get to the next part where we have to do self study, 30 minutes of self study, then we have to spend 15 minutes each on asking questions. Okay, so self study, first of all, uh, mm, okay, let's ask a question that mm, shapes in chemistry, something like this. No, uh, molecules shapes. So hexagon, etc. So looking at the images, okay, these are hexagonal shapes. As I said that one, two, three, four, five, six. So let's get into the detail. How many carbon atoms does the hexagon have in it? Okay, the hexagon molecule of benzene composed of six carbon and six hydrogen atoms is one of the most beautiful structure in organic chemistry, commonly known as turtle shell. The structure regarded as a symbol of field. Okay, so one more thing I have to ask that uh, what is parent chain? The parent chain is the longest continuous chain of carbon atoms. If no largest chain contains be found because two or more chains have the same length. The parent chain is the one with the most branches. Okay. Now is called the structure of methyl. Let's do some research on this structure of. Okay, this is the structure of methyl chlorophyll. So let's get into it. This is that's the structure of methyl chlorophyll. Okay, so this is uh, methyl chlorophyll group. So with explanation. Mm, I will say what is, so I can get to know about it. So let's get to this. Okay. So primary has a flammables, compressed gas, irritants, uh, molecular formula C4H6, and molecular weight 540.09 gram mole. Okay, this is a structure. Okay, for Okay, molecular batteries. So, what can I? Uh, which? How? Why carbon make another? A carbon-carbon bond is a covalent bond between two carbons atom. The most common form in the single bond, a bond composed of two electrons, one from each of the two atoms. The carbon-carbon single bond is a sigma bond and is formed between one hy- hybridized orbital. Okay, sorry, unhybridized orbital from each of the carbon atoms. So this is not justification of my explanation. I doesn't have asked that about. Okay, I will go with it. So
Hands down, carbon is perhaps one of the most important elements fundamental to living. A highly abundant element found on Earth, you can find carbon's presence everywhere. It is located in the compound chlorophyll, giving plants its green color. It is the building block for numerous organic compounds within our body, such as proteins, DNA, and amino acids, to name a few. Of course, it is also found in numerous simple and complex organic compounds that are synthesized to make so many of the commercial products we use on a daily basis. What contributes to carbon's vast abundance throughout the Earth? One reason may stem from the versatility of bonding with carbon. Before we address these different bond types, let's go over the molecular shape of carbon. Molecular geometry refers to the ability to view the 3D arrangement of atoms in a given molecule. Molecular shapes come in many flavors. You have bent shapes and trigonal planar shapes. There are shapes that can be linear. When carbon forms four bonds with atoms, its shape is called a tetrahedron. This diagram shows the basic tetrahedron shape of a carbon atom. As you can see, it mimics a pyramid shape, a sharp point at the top, and a wide base for the bottom. This is a great way to remember the molecular shape of a tetrahedron for any given molecule. Each of those four bonds extending out from the carbon is available for other atoms to bond to. But
okay.
why four bonds? Carbon has four valence electrons in its outer shell. However, when bonding to other atoms, it obeys the octet rule, ensuring eight valence electrons in its outer shell are present. A valence electron is an electron that occupies the outer shell of an atom.
Hmm.
Each bond in a molecule equals two.
Oh, what should I do? Uh, that's a good lecture, but let's get into it. Okay. Spiral structure like the one pictured here can replace batteries in the future. Okay, because this is the hexagon. Okay, this will this article will be helpful because they can store energy like a spring and conduct electricity. The structure is a tiny nanotube that consists of entirely of carbon atoms. Nanotubes are made in labs, but carbon-based compounds are also the most commonly naturally occurring compounds on Earth. More than 90% of all known compounds contain carbon. Do you know why carbon is found in so many compounds? Carbon everywhere. Carbon is a very common integrant for of matter because it can combine with itself. So that's how carbon. This will be helpful. A carbon atom can form covalent bonds with other carbon atoms or with the atoms of other elements. Carbon often forms bonds with hydrogen. Compounds that contain only carbon and hydrogen are called hydrocarbons. Methane CH4, which is modeled in figure below. This is CH4 methane, okay, is an example of hydrocarbon. In methane, a single carbon atom forms covalent bonds with four hydrogen atoms. This diagram on the left in the figure below shows all the shared valence electrons. The diagram on the right in the figure below, called a structural formula, represents each pair of shared electron with a dash. Okay, so how many bonds do the carbon atoms share in each of these compounds? In ethane, the two carbon atoms share a single bond. In ethene, they share a double bond, and in ethine, they share a triple bond. So I have a question that uh, table of methane, propane, protein. So okay, methane is the first structure formula of methane is CH4. So ethane CH2H6. We can also write CH3CH3. Propane C3H8. So butane C4H10. Pentane C5H12. Hexane C6H14. Heptane C7H16. Octane C8H18. Nonane and decane. Okay, so now let's get into okay 2 cyclopropyl. Why? What is cyclopropyl? First of all, a cyclopropyl group is a chemical structure derived from cyclopropane is typically produced in a okay, this is cyclopropyl group. So this is cyclopropyl group. Okay, 2 cyclopropyl means 1 2, I think. uh, what is 2 cyclopropyl? 2 cyclopropyl. Let's check. Okay, this is 2 cyclopropyl. So I said that this is 2 cyclopropyl. The other one is 3 ethyl. What is 3 ethyl? Okay, this is 3 ethyl. Let's check the structure. This is the structure of 3 ethyl. 1 2 and 3. Okay, how can I say that? So 3 ethyl Phenol is an organic compound with the formula C2H5C6H14OH. It is one of three isomeric ethyl phenols, a colorless liquid. It occurs as an impurity in xylenols and as such is used in production of commercial phenolic resins. So nothing much about this. So let's get to another one. It's without AI, it's being difficult to study. I think the branch at carbon X is called methyl cyclopropyl. So difference. Let's search. So let's check this. So this is methyl and propyl and cyclopropyl. Difference between. Let's check for the difference of. Uh, okay, let's read this. In organic chemistry, a propyl group is a three-carbon alkyne substituent with chemical formula. Okay, for the linear form. This substituent form is obtained by removing one hydrogen atom attached to the terminal carbon of propane. A propyl substituent is often represented in organic chemistry with the symbol Pr. Okay. An isomeric form of propyl is obtained by moving the point of attachment from terminal carbon atom to the center carbon atom named isopropyl or 1-methylethyl. To maintain four substituent on each carbon atom, one hydrogen atom has to be moved from the middle carbon atom to the carbon atom which served as attachment point in the n-propyl variant. Okay, so let's linear propyl is sometimes termed normal and hence written with the prefix n propyl as the absence of the prefix and does not indicate which attachment point is chosen. Absence of prefix does not automatically exclude the possibility of it being the branched version or isopropyl. In addition, there is a third cyclic form called cyclopropyl or C-propyl. Okay, now it is not isomeric with other two forms, having a different chemical formula, not just a different connectivity of the atoms. So, n-propyl acetate is an ester which has the n-propyl group attached to the oxygen atom of the acetate group. Okay, this is about propyl group. So let's can't find this form anywhere. Okay, this is 2 cyclopropyl for ethyl. One, two, three, and four. This is 4 ethyl. One, two. This is three, and this is 4 ethyl. And one, two cyclopropyl. Two, I don't. What is the name of shown compound? One cyclopropyl, two ethyl, four methyl pentane. So, so we are here at 2 cyclopropyl, 3 ethyl, 2 4 4 trimethylhexane. What is the name of the shown compound? One cyclopropyl, two ethyl, four methyl. I don't know. There is no such information available of these things. So let's jump to the another one. Which of the following molecule is not a organic molecule? So first of all, let's check list of organic molecules. List of organic molecules. So here I have. Okay. So how can I get the list? We'll go with images. Okay, let's list of organic. An organic compound is a member of a large class of gaseous, liquid, or solid chemical compounds whose molecules contain carbon. Organic molecules are used by human beings in foods, pharmaceuticals, fuels, etc. Check the complete list of organic. Okay, methane is organic, butane, ethylene. So is benzene. Benzene is organic. Oh yeah, organic. So this is on hydrogen cyanide. Tetrafluoromethane. I think if methane is tetrabutoxybutane, methane butane is organic. Hydrogen cyanide. So I have to search for cyanide. Okay, cyanide is not. Okay, so the right answer is hydrogen cyanide. Get it? How many valence electrons are present in butane? So let's search this question. And 26 valence electrons present in butane. So the answer is 26. Okay. Uh, which of the following functional group is most likely to emit a pleasant uh, which functional groups? So So what I get is RCOOR dash, which is in RCOR dash. I think I found that. Uh, oh,
Welcome back. I'm that chemist. And
this is ethers. Okay, so RCOOR dash. This is called Easters. So structure of Easter. This is Easter. So Easter has a pleasant sweet smell. Okay, can you answer the previous question? Partition in hydrogen. No, there are oxygen atoms, but they are not bonded to any hydrogen. Okay. Which molecule will have highest boiling point? Uh, why boiling point of molecules increases? So let's check with this. Large molecules have more electrons and nuclei that creates van der Waals attractive forces, so their compounds usually have higher boiling points than similar compounds made up of smaller molecules. It is important to apply this rule only to like compounds. So, number of electrons in, can I search this? Number of electrons in this 18 valence electrons, and this has 18 valence electrons, and so so two atoms of carbon, two atoms of oxygen, four atoms of, okay, minus 4 4 minus 4 4. So I think that was the correct answer because it has 18 valence electron. So let's move on to the next one. And how many hydrogen atom does an alkane with n carbon atoms have? An alkene with hydrocarbon with the general formula CnH2, and this means that for every carbon atom there are two hydrogen atoms. So if an alkane has 20 carbons, okay, 20 carbons, it will have 2 multiplied by 20, 40 hydrogen atoms. Okay, so H, if H is equal to N, then C is equal to N, then H is 2N. So uh, how many hydrogen atoms does an alkaline with N carbon. Okay, if N is carbon, if there is 2N, then the hydrogen atoms would be 4N. But as it is N, so it is 2N. Sorry for this. It will have 2 multiplied by 20. For, okay, so now let's get to the this point. Which molecule have London dispersion forces? First, what is London dispersion force? The London dispersion force is the weakest intermolecular force. The London dispersion force is temporary attractive force that results when the electron is two adjacent atoms occupy positions that make the atoms more temporary dipoles. Okay, so argon, hydrogen gas, fluorine gas, methane have London dispersion forces. So uh, ethanol I have selected as ethanol, heptene, all of them should have London dispersion force. Okay. Assume each substance in a liquid at room temperature. Which of these following molecules can mix with water? So, I guess acid reacts with ethanol in the pressure of concentrated sulfuric acid as a catalyst to produce the ester. Ethyl ethanol. The reaction is slow and reversible to reduce the chances of the reverse reaction happening. The ester is distilled off as soon as it is formed. Okay. Uh, they both can participate in hydrogen bonding. Water is also able to do so, like dissolves like. Okay, okay. Where would you expect methanol to place in this list? Uh, or below ethanol? Methanol is used to place above. This question I think doesn't make any sense because I have to provide this picture. So uh, I think that's it for this session. We should have to move on the next part where we have to give these questions. So let's get to the it. What are the IUPAC rules or naming straight chain alkanes? So this is the first question. Organic chemistry. The increasingly large number of organic compounds identified with each passing day. together with the fact that many of these compounds are isomers of other compounds that require of the other compounds requires that a systematic nomenclature system is be developed. Just as each distinct compound has a unique molecular structure which can be designated by a structure formula, each compound must be given a characteristics and unique name. As organic chemistry grew and developed, many compounds were given tribal names which are commonly used and recognized. So, name formula methane CH4, butane C4S10, acetone CH3COOCH3, toluene CH3C6H5, acetylene C2H2, ethyl alcohol C2H5OH. Such common names other have their origin in the history of the science and the natural source of specific compounds, but the relationship of these names to each other is arbitrary, and no rational or systematic principle underlying their assignment. The IUPAC systematic approach to nomenclature, non-rational nomenclature system should do at least two things. First, it should indicate how the carbon atoms of a given compound are bonded together in a characteristics lattice of chains and rings. Second, it should identify and locate any functional groups present in the compound. Since hydrogen is such a common component of the organic compounds, its amount and location can be assumed from a tetravalency of carbon and need to be specified in most cases. The IUPAC name nomenclature system is a set of logical rules devised and used to organic chemists to cir- circumvent problems caused by arbitrary nomenclature. Knowing these rules and a given structure formula, one should be able to write a unique name of every distinct compound. Likewise, given a IUPAC name, one should be able to write structure formula. In general, an IUPAC name will have three essential features: a root or base indicating a major chain or ring of carbon atoms found in the molecular structure, a suffix or other elements designating functional groups that may be represented in the compound, name of substituent groups other than hydrogen that complete the molecule structure. Okay. Hydrocarbons having no double or triple bond functional groups are classified as alkane and cycloalkanes, depending on whether the carbon atoms of the molecule are arranged only in chains or also in rings. Although these hydrocarbons have no functional groups, they constitute the framework on which functional groups are located in other classes of compounds and provide an ideal starting point for studying and naming organic compounds. The alkanes and cycloalkanes are also members of a larger class of compounds referred to as aliphatic. Simply put, aliphatic compounds are compounds that do not incorporate any aromatic rings in their molecular structure. So the IPAC system requires first that we have names for simple. So let's move to the other one because this has so much detail. Physical characteristics of organic functional groups. Okay, let's search the website provided. Uh, copy, create a duplicate, paste. Okay, master organic chemistry. Okay, this is the website. Okay, is the most important functional group. Functional groups are specific grouping of atoms within molecules that have their own characteristics properties regardless of the other atoms present in a molecule. Common examples of functional groups are alcohols, alkenes, alkynes, amines, carboxyls, acids, aldehydes, ketones, esters, and ethers, among others. In a typical sophomore organic chemistry course, there are about 15 key functional groups with another group of 10 or so that make consistent appearance. You will meet others too. This is just a selection of the most common. A functional group is what we call a specific grouping of certain atoms within molecules that have their own characteristics properties. So, here are some of the most commonly encountered functional groups. Note that R is a placeholder or for a generic carbon substituent. So R is a substituent. So now let's get to the other one. Do these names sound familiar? Propane, dinolol. No, this I think no. So let's. Alkanes are hydrocarbons containing no multiple bonds. Alkane substituents are called alkyl groups, which refers to alkane groups lacking OCH bonds such as methyl, ethyl, or propyl. Common examples of alkanes are methane, ethane, propane, butane, and octane. The CH bond is highly covalent and alkanes are very non-polar. They do not mix with water. Alkyl carbons are sp3 hybridized and have tetrahedral geometry about the carbon. You can often think of alkyl group as a spectator, a functional group of organic chemistry observation as R, with the exceptions of free radial substitution and of course combustion. Alkanes don't undergo a huge number of different reactions. They tend to provide the backbone of the most organic molecules. Alkenes are hydrocarbons with one or more carbon-carbon double bonds. Common examples are ethene, propane, and butane. Alkene substituents are called alkaline groups. Nile is often used to refer to CH double bond CH2. Alkaline carbon are sp2 hybridized with a trigonal panel geometry. Let's okay intermolecular forces types. Let's check this. Okay. What are intermolecular forces? Intermolecular forces, often abbreviated to IMF, are the attractive and repulsive forces that arise between the molecules of a substance. These forces mediate the interactions between individual molecules of a substance. Intermolecular forces are responsible for most of the physical and chemical properties of matter. Forces also exist between the molecules themselves, and these are collectively referred to as intermolecular forces. Intermolecular forces are mainly responsible for any physical characteristics of the substance. Intermolecular forces are responsible for the condensed states of matter. The particles making up solids and liquids are held together by intermolecular forces, and these forces affect a number of physical properties of matter in these two states. Types of intermolecular forces: dipole dipole interaction. Dipole dipole interaction are attractive force among polar molecules. Polar molecules have permanent dipoles that are formed due to difference in electronegativities of the atoms that are associated with the covalent bond. The partially positive portion of one molecule is attracted to the partially negative portion of another molecule. Dipole-dipole interaction occurs in HCl molecules. Chlorine is comparatively more electronegative than hydrogen, and it therefore occurs on partial negative ion dipole interaction. These interactions are similar to dipole-dipole interaction except for the fact that they arise between ions and polar molecules. When NaCl is mixed with water in a breaker, the polar H2O molecules are attracted to the sodiums and chloride ions in the beaker. The strength of this interaction depends on the magnitude of the dipole moment, size of the polar molecule, size and charge of an ion. Ion include induced dipole interactions. In this type of interaction, a non-polar molecule is polarized by an ion placed near it. The non-polar molecules, upon obtaining a charge, behave as induced dipoles. This interaction between an ion and an induced dipole is known as ion-induced dipole interaction. Dipole-induced dipole interaction. These interactions are similar to ion-induced dipole interaction. However, the differentiating factor is that non-polar molecules are transferred into induced dipoles due to the presence of polar molecule nearby. Okay, dispersion forces or London forces. I have already read that. So, no, uh, this is important to read. It operates for a short distance and it the weakest force. This kind of forces arises due to the movement of electrons, thus creating temporary positive and negative charged regions. So, London dispersion forces (LDF), also known as dispersion forces, London forces, instantaneous dipole-induced dipole forces, fluctuating induced dipole bonds, or loosely as van der Waals forces, are a type of intermolecular forces acting between atoms and molecules that are normally electrically symmetric. That is, the electrons are symmetrically distributed with respect to the nucleus. They are part of van der Waals forces. The LDF is named after the German physicist Fritz London. They are the weakest of the intermolecular forces. Okay, so let's jump to the this document to do some exercise. A molecule with 5 carbon must always be called pentagon pentanes. In regards to naming, the numbers assigned to each carbon atom in an organic molecule usually must be the dash possible. In regards to naming, the numbers assigned to each atom in an must be don't know about it. What is the formula of the number of hydrogen in an alkane? Uh, I think 2n. Esters and carboxylic acid can thought of opposite in what regard? One contains two oxygen and the other contains only one. Size carbolic acid, I think it's first. Oh, I think it's also LDFs. London dispersion forces can be stronger than H bond when the molecule with the only LDFs is sufficiently dash than the molecule with H bond. I don't know much about this. So all molecules containing carbon are organic molecules. True. A carbon can make a maximum of 4 bonds and theoretically a minimum of 1 bond, I guess. Yes. No. A carbon can make 6. Carbon makes a minimum of 2.42. The presence of an alkene can be tested by first adding one another alkene. The presence of an acid can be tested for a base. Despite ethanol being smaller than butane, it has higher boiling point due to being harder to metabolize, its ability to participate in hydrogen bonding, its lower number of hydrogen atoms, its smaller size. Okay. Uh, Despite ethanol being smaller than butane, it has higher boiling point due to being harder to metabolize, its ability to participate in hydrogen bonding, its lower number of hydrogen atoms, its smaller size. a smaller size, a large amount of LDFs. I think it's so. Yeah, we are at here, and so let's submit the task. So let's view the score. A molecule with five carbon must always be called when not enough information. Okay, in regards to naming numbers assigned. So let's, in regards to naming the numbers assigned to each carbon atom in an organic molecule, usually must be possible. So uh, for this, it's lowest, smallest. What is the formula of the number of hydrogen in alkane? 2n, 2n plus 2. Okay. Ester can carboxylic acids. Okay. LDFs can be stronger, larger, or bigger. All molecules can. So many are wrong. 10 to not a good research, I guess. So let's have a break and jump to the posters now. So yeah, let's get to the post test. So I will start a timer of 20 minutes. So it started. Let's jump to the test. This is Osama Ahmed Siddiqui and this is post test. Control C and okay, let's start the test. Use the diagram, answer the following question. This is again a hexagon. So there are dash carbons atoms in the parent chain. It is called 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, so now numbering of this molecule will begin at carbon, I guess, alpha. Use this information along with the previous diagram to answer the following five questions. Consider the possible branches at carbon X, Y, and Z. The branches at carbon Y is called methyl ethyl. So so which carbon can only make one more bond? Uh, X Y X Z Y Z. One, two, three. One, two, three. One, two, three. One, two. I think all of them can make one more bond. Which carbon is able to make two bonds? I think X, because X has only two bonds, one, two. It can easily make a three and four bond. What is the name of? I don't know about this much. So methyl, the addition of a methyl group onto carbon dash and dash would add an extra side chain. Uh, this will be, I guess, the addition of carbon. If we addition of, I guess, alpha, beta. Which of the following molecules is not an organic molecule? Uh, Not an organic. Chloroform. And I think chloroform. How many valence electrons are present in methane? Methane, I think, has four valence electrons. Each of the following functional group is most likely to taste sour. So this is sweet. I think this is sour. Can you answer the previous question? Participate in a hydrogen bonding? No, no. The Yes, it participates in hydrogen bonding. Which molecule will have the lowest boiling point? Lowest boiling point, I guess it will be how many hydrogen atoms? Oh, this will be 2n. Okay, sorry, I have missed that. Which elements have the same number of electron as methane as valence electron? Okay, carbon, I guess. Use this information. Okay, but which molecule can partake in dipole interactions? So dimethyl ether only, dimethyl ether and methonic acid, the dimethyl ether, methonic acid, and decano. Oh, I don't know. I will make a random guess. Assume each substance is a liquid at room temperature. Which of these molecule can mix with tetrafluorate, tetrafluoromethane? So I guess it would be methonic acid. Okay, I will go with my methyl cyclopentane. So why can they fix with C4, C4, CF4? I don't know about this question much. Despite that, methonic acid has much fewer carbon atoms than methyl cyclopentane. Its boiling point is much higher. Why? Methanoic acid can participate in hydrogen bonding. Methonic acid has oxygen atoms. Oxygen atoms increase boiling point. Methyl cyclopentane is symmetrical and methonic acid is not. Methyl cyclopentane is branched and methylpentane. So I will go with random donor. Where would you expect propanol to place in the list? Between diethyl ether and methyl cyclopentane, between methyl cyclopentane and methonic acid, between methonic acid and taconic acid, below taconic acid. So I will. The addition of methyl group to which carbon would not produce a molecule with a side chain. The addition of methyl to which carbons would produce the same molecule. So it will be. I say that I think 26. What is the maximum number of propyl groups that can be added to carbon alpha? So I think it's zero. The electron in benzene molecule are not fixed on one atom. They are. I don't know about much about this, so I will leave this. A neutral dye has been discovered. It is polar. It does not have any natural odor or color. Without the presence of another chemical or will a chemical in the lab, you are presented with five wells. How will you attempt to detect its presence? Add orange dye. Artificial orange dye will absorb and cook the compound. Add water, a polar compound with red dissolved in water. Uh, Titrate using HCl. HCl will decrease the pH past 7. This indicates the presence of acid. Uh, Titrate using NaOH. NaOH will be neutralize the solution. So I have read this uh, Add orange dye, artificial orange dye will absorb into the compound. So add orange dye, artificial orange dye will absorb into the compound. Add water, a polar compound with readily dissolved in water. Uh, I will go with titrate. So yeah, let's view the score. So it's six, nothing special as uh, it is the same, nothing special. So I guess in my opinion, searching online is quite hard for to do this. So I'm not confident about this sort of study. So let's fill this form. Uh, okay, let's